So today we have four sections. So first one, I will share about our use cases in Shopee, and the second section is about our proposed solutions. And the last one, the third one is the online adoption. I'll share a little bit about the metrics and how is the performance of StarRocks. The last one for metadata cache acquisition will be covered by my colleague Guan Yin. I'm the tech lead of data service platform in Shopee. So what this application does, so it actually converts any SQL into a RESTful API. So in Shopee, that you can imagine we have a lot of systems such as campaign bidding system, seller center, logistic fulfillment platform. So all those systems actually need a cooperation between the BI engineers and backend engineers. So for BI, they every day or every hour they will calculate a great amount of metrics. Example, like the ads click-through rate, the logistic fulfillment rate, and all that other metrics need to be shown to our sellers and logistic providers. So the BI engineers really trying to build this query directly on top of Hive. And the backend engineer is able to use a RESTful API to access and show them into the web pages or our applications. So this is platform, the everyday metrics. So we serve about 400 million web queries every day. And so as you know, that for any online applications, usually they have four major requirements. The first one is they require latency. They are very latency sensitive. So they want the latency, every single API query, the latency is consistent. So whether it's 1 millisecond, whether it's 100 milliseconds or 5 seconds, but never mind, you need to make sure that it's consistent so they can manage their expectation. Secondly, usually the API query is running under a wide range of UPS. So sometimes can be less than 1 query per second, but sometimes can be up to thousands of UPS. And the third one is the backend system usually want any changes that happen in the data warehouse to be reflected through the API as soon as possible. So the data timeliness is also very, very important for them. And lastly is the uptime. So we need to guarantee the user availability of this API and the error rate, etc. So then you will notice that usually the bottleneck comes from the data warehouse, the components. As you can imagine, if you have a cluster-like engine in your hand, a BigQuery and any other the engines, so they cannot fulfill those requirements. So in Shopee, that the common practice before that we will involve different type of engines like ClickHouse, like RDS into this part. So of course, increase the complexity of the whole pipeline. That you need to either ask the BI engineer to know how to dump the data set into the ClickHouse or RDS, or ask the backend engineer to build this Spark pipeline, load the data from Hive to RDS. But anyway, it's so complicated for them. In order to resolve this problem, and we proposed the Materialized solution in StarRocks. So basically, it's a space-time trade-off. This is very general query, everyday running Shopee. So you will see this red blocks. It's a CT declaration. So every BI engineer is very comfortable with this form of query. And inside this query, you will fetch two key information. So first one is what exactly the tables involved that you need to build this predefined data set. The second is the data column, which you can use this one to define partition keys. So you can imagine if you build a materialized view based on this row, you can actually leverage the TTL feature to manage the whole the data set, the storage that you need. So the whole pipeline then becomes like this one. So first of all, that we in the StarRocks we create a machine by the CC to clarify the customers. And because we already know what table is involved. So what we can do is, no matter what the DML statement is executed in the Hive, so we will receive a event listening. So Shopee has a centralized event bus for every data change. So then we will know, okay, this underlying table has been changed. So then we need to refresh materialized view. And most importantly, that if this city contains any particular key, meaning you have a data point inside. So what we can do is this refresh materialized view statement can implement a partition-based incremental refresh. So it's going to be very quick. By our observations, every materialized view now, it takes about less than 1 minute to refresh, to rebuild the whole the data change. So it's actually quite quick. And the final API query coming into StarRocks no longer going to the Hive or going to the data. So we directly query the materialized view, improve the query performance. So this is the metrics right now. We actually did start investigation of StarRocks more than 1 year ago. And we built this pipeline and trying to launch to the production since last October. So in the recent half a year, we already adopted to 4 major business units. The Ad-Hoc creation is about Shopee Live, and the supply chain fulfillment. So Shopee has a platform to help the seller to delegate logistic services for them. And the security infrastructure. So every day they monitor the traffic query coming to our components. So they monitor any data leak risk, and also the anti-fraud team. So now we have 6 independent StarRocks clusters running for this kind of what we call the performance booster up project, and over 100 active API every day serving the model business. So we serve 2 million queries a day. This for the typical latency, this is a very, very typical one on our daily work. So most of the query is just below the 100 milliseconds. During this adoption, we do find quite a lot of the common problems. So first of all, that because we involve the materialized view, so if you are familiar with any engine, come along with a materialized view, that unexpected overloading is always come here. Is always naturally come along with this engine. So what we actually try to resolve is to, first of all, that we have a CPU soft and hard limit. So soft limit is when you launch this cluster, we will assign a number of cores to this cluster. But if you really have a CPU spike, for example, this cluster is refreshing the materialized view, but it has a large size mismatch, so the CPU will go very, very high. Then we give you a hard limit. So basically, you can reach more resources from the whole cluster, from the whole Kubernetes cluster. And secondly, is we set a max usage of RAM, so trying to avoid overhead. So you can imagine if you really need a lot of memory at the same time, and your task cannot provide such resources, so the whole cluster will need to reboot, for example, your backend reboot. And we also enable the distributed scale feature. So this is a very important feature for availability. So once the memory usage has reached the max usage limit, so all your temporary storage will be split to your disk. So which can give you a quite important benefit that you only need to monitor how much your disk right now. You don't have to worry about whether you have enough memory or CPU. You just care about your disk. If your disk has much more overhead, so you don't really worry that any unexpected batch size. The second one is in Shopee, we try to manage every cluster cost. So that's why we introduced the district detail. So we encourage people to use the data set with the data column. So we can define TTL to manage a long-term, the acceptable or affordable cost in this. And for CPU hard limit, we don't charge any cluster for that. So basically, it's a shared resources within the organization. So you always have the privilege to risk for that, but we don't charge you. And for common operations, we actually deploy the whole StarRocks cluster in the Kubernetes. So for front and back end, we're possible to split the release plan. So thinking some version or new feature we want to release, but you only involved in the front end. So we only need to restart all the front end node. That's it. The last one is something we're right now testing for the front-end query routing. So this thing only happens that you need to reboot your backend node. So thinking a connection to your back node and maybe run a query on this node. If you're trying to reboot it, of course this query will fail. But how we can control this exactly? We want the front end to notice the unhelp the second node, the work node, and trying to do one time try, just forward into another healthy backend node. So we can guarantee the ability. All right, so this is my the sharing. So next session about metadata optimization, I will provide my
Let's start. Hello everyone, I'm Guan from Shopee team. Today I'm going to share something about the metadata tag optimization in Shopee Ad-Hoc class. Before talking about the optimization, I want to use some current situation of Ad-Hoc on StarRocks Shopee. Currently, we already built 10 independent Ad-Hoc clusters with over 1,000 DE nodes, and it will handle over 3,000 queries every one day. And you can see here the performance for StarRocks Ad-Hoc is better than Presto, and you can see the P50 and P90 is much lower than Presto. Also, we already supported for 4 scenarios, and they are high 2D, panel, and ozone file system. But at the beginning of the rollout, we still meet some challenges. The first two are bypass rate and success rate is very low, and the third is current result mismatch rate is relatively high. After I dig into the root cause, mainly because of the metadata cache. So here, what I want to show about is some optimization to reduce the mismatch rate. Before talking about the optimization, I want to show something about the advantages and disadvantages for metadata cache. Let's begin at the advantage. You can see here it is a query profile for a simple select query, and you can see from the graph that the time cost for the planner reduced a lot because of the metadata cache. So that we can see that the more tables and the partitions involved, and the benefit will be greater. Also, another advantage is that the metadata cache will reduce the pressure of HMS. But every point has its two sides. There are still some disadvantages for metadata cache. The first one is that sometimes when users run the same query in different engines like StarRocks and Presto, they might get different results. So they will complain why the result is different. Also, some data quality check will be blocked because of the wrong results. And also mismatch results due to the incomplete raw function will be hard to tell. And here, I also want to introduce the metadata cache and in StarRocks and its refresh mechanism. The metadata cache consists of two main parts. The first part is the table-related cache, and the second part is the remote file cache. The table-related cache contains 5 caches. They are table cache, partition name cache, partition cache, and the table and partition set cache. As for the table cache, it will store some information like column types, and the location and table type. Also, for the type view, it will store the view topology. As for the partition name cache, it will store all the partition names for one given table. And as for the partition cache, it mainly stores some partition information like the partition file path. As for the table and the partition static cache, they will store the column static information in table or partition level. And this information will be used by CPU. The next will come to the expire and the refresh mechanism. For all the table related cache will expire 1 day after the key is written. And as for the table partition names and the table static cache, it will refresh asynchronously 1 minute after write. But for the partition and partition static cache, it will never refresh. The next part is the remote file cache. The remote file cache contains the remote file name that BE node will need to read, and it will expire 3 days after the key is written, and it will refresh 1 minute after it is written. Here, another thing I want to highlight here is that the partition names, partition, and the remote file cache will affect the query result. So here comes to the solution. I will divide the solution into 3 aspects. They are the 3 most important HMZ table types. The first one is the measurement table. From our daily DoD, we found that for example, when some user write some data into a new partition and then they use StarRocks query the table, they might not get the latest partition data. After we debug into the case, we found that it is mainly because of the partition name cache. And so here, the fourth operation that we will remove the cache for the partition name. And also there are some cases like that. For example, some user will reload data into one table, or some user will do some operation like a merge small file, and then they use StarRocks to query the table. They might get the wrong result because of the partition file is changed, but in our case, the file name haven't changed. So here I set the remote file TTL to 2 minutes and make it will not refresh. The next part is for external table. For the most case, that external table means is same as the management table, but there is still one special case for external table is that, as we all know, users can set the partition file path for the external table, and then as I mentioned before, the partition cache will never be refreshed. So, for example, when user set up a new partition file in the external table, and then after that they will use StarRocks query, then they will always get the wrong data. So here I implement a logic that the partitions from external table can be refreshed, so to solve the problem. And the third part is the virtual view. It is a very real use in Shopee. That is, some users will check the view logic in the virtual view, and then they will set up some data quality check for it. Then, when the data quality check is checked, it triggers the virtual view might not use the latest logic, and then the check will be failed. In some serious cases, some downstream job will be blocked. So here I implement a logic that we will always get the latest health view when we are analyzing. Here is the example that we create for the catalog we use for the Ad-Hoc task. You can see we remove the partition name tag and we set up some remote file. some remote file cache sketch next time. After all the operation is taken, you can see the mismatch rate reduced from 3.1% to 0.9%. And I took one day mismatch record and dig into it. All of the mismatch are related to the incomputable function. And we also have some future plans for the Ad-Hoc cluster. As I mentioned before, the partition statues will also be used for the CPU, but it will not reflect. So I can design some suitable background refresh mechanism for the partition static test that may make our query performance much more better. And also for the DQC or dashboard cluster, I can try out some catalog without metadata cache. As you know, the DQC or some dashboard will not query so many partitions, so that means the query will be very simple for that. Thank you for everyone.